Hello, everybody. Welcome to this seventh episode or seventh session of the Civo DevOps Bootcamp. My name is Kai. I'm a developer advocate / developer here at Civo. And today I'm joined by two Civo ambassadors, Mac and Alistair Hay. And today we'll be talking about automating everything. And one of the big things with automation and this session is that it kind of follows on directly from what we've been doing previously in these sessions. So if this is your first time tuning in, make sure that you can absolutely watch, but it will make more sense if you watch through the previous 6 sessions. There is a quiz that is linked from the description of the video. So make sure that once you've watched this, you complete the quiz and sort of put your learnings to the test. And so if there's no objections from Alistair and Mac, I'm going to hand over first to Mac to give a quick introduction about himself, and then maybe Alistair, and then we'll get started.
Hey everyone, I'm Mac. I work there for a company in South Africa, doing all kinds of things around cloud and Kubernetes especially. I've been on the journey with Civo for a while. Pretty awesome platform to be using, and really enjoying that. Hoping to not say too many times today. But to give some good insights and hopefully prompt some nice questions from everyone that's participating today around automating and what do we mean by everything when we say automate everything. Over to Alistair.
Yeah, hi again, everyone. If you've watched the previous run of sessions, I'll have been a fixture in the first few, but after a short break, I'm happy to be back. If you haven't watched them, I'm a cloud native platform engineer, Kubernetes, cloud, Terraform, automation, DevOps, all the things we've been talking about basically through this series. So hopefully you'll learn something. And I believe Mac is going to kick off, and we'll go from there. Any questions, fire them in the chat. We'll be looking at those. We'll be talking about them. So, please drop in, say hi. Some familiar faces already. So welcome.
Yeah. Definitely. Any questions you might have, just ask them. I will put them to Mac and Alistair midstream, or then we'll just come to them at the end if we're super busy with some sort of really technical concept. But please don't hesitate to put all your comments and questions into the chat. So Mac, do you wanna get started?
Sure. So DevOps and the DevOps Bootcamp. What is DevOps? No, I'm not going to answer that question straight away, and I don't have to because you need to go back and have a look at a couple of weeks back. But this is a journey around DevOps and what it means. In the previous session, there was a focus on quick feedback loops or rapid feedback loops in order to get the desired outcomes, in order to be able to get your speed, your agility through your applications or infrastructure. Today we're talking about automation and automating everything. So one of the first things that I was thinking about in terms of automation from that was around automating the mitigation or responses to alerts. So yes, the alerts themselves is a kind of automation, I guess, because you set them up and no one has to keep watching to make sure that the application is running. You get an alert. But what do you do then? Great, there's an alert. You need something to happen, something programmatic or automated to occur. And one of the things you could do is automated mitigation. So for example, you get an alert saying your applications are consuming all of the memory on your Kubernetes cluster. An appropriate automated response to that would be to fire off a job that will extend the number of nodes or scale up your node group of your Kubernetes cluster. So and while I say that, I also am aware that, great, that sounds cool. But all automation usually starts with somebody at some point doing some preparation. And that's maybe the difference between an automated setup and configuration compared to just an ad hoc approach. In that when you are going to automate something, you have to put in a bit of effort almost ahead of time. That doesn't obviously stop you from adding automation as you go, because automation isn't a binary state. You're not likely to have everything automated. You will be starting at some point in what you're wanting to automate. And there's probably going to be things that you can't automate. In a lot of the places that I work, a lot of what I do is system integration, and there's a lot of those components that systems that I'm integrating need to talk to, of which several of those things I don't have control over. So when you're writing your own application and you have end-to-end control of your application itself, you can almost automate end-to-end. So we'll look at some of that in a moment. But when there is components in your chain of events, in your integration pieces that you don't control, it may be that you're limited in what automation you can do there. Some of the things that jump into my head around that is changes to third-party integrations. If someone's got a business process management application that they patch on a monthly basis, you can't automatically change your APIs and the versions of those things necessarily, although that can be done to a degree. So we just wanted to kind of put a sort of manage the expectation in terms of where's a good places to start with your automation versus kind of where's a bad place to start when you're looking at automation. So fundamentally, start with the things you control if you want to automate. So any comments or questions at that point?
Yeah, I mean, there's an interesting thread that you can pull out of that, which is if something doesn't happen very often, if your third-party API changes once a month and its changes are relatively small, you might want to just handle that as part of process and going out and checking and making those changes. But if it's something that happens 40, 50 times a day, you're going to get more benefit out of automating those things which are either happen a lot or take a really long time to do manually, or are very error prone and stuff. So, when you're starting out on this journey, it's not just, write down a list of everything you could automate and start at the top. It's going to be identify your biggest pain points or your biggest things that cost the business the most.
Yeah.
And start to tackle those first. So.
And one thing I'd sort of just extend from that is kind of what we talked about in some of the earlier sessions, which is if you have, if you don't have anything automated, the first thing you automate will be, you'll be that much better off and that much more able, right? So, you kind of have to sort of pick the things that will have the biggest impact. But if your current rate is 0, then pick something,
I absolutely, and I really like that idea of saying, look at what is the most value or most cost to the business while you're doing that. One of the things that certainly helps and enables automation in an integration space is having an API, having access to be able to make those requests, because then whatever tooling you use, and we're going to come and look at tooling in a moment, whatever tooling you use will then enable you to programmatically and thus automatically, or based on responses to an events, have it do the work for you, where you don't have to sit and say, okay, cool, now I need. It's measured in that sense. And once again, then we kind of refer back to last week's or the previous times around feedback loops and things like that, because those provide the metrics and the event states that tell you when you need to trigger an automated event. Any questions? Maybe just a query, just guys in the chat, just keen to hear some ideas. What do you think are really the benefits of automating something, and what are potentially the pain points of that? I think that would be quite quite nice to hear get some feedback in the comments. We're talking about automation, but maybe there's a kind of thing. Well, why? What's the benefit to doing this other than I don't have to wake up at 3 a.m. to click start on something.
Yeah, I mean, the API thing's a good point. And we can link this back to some of the other things we've talked about in the past, like the rise of cloud computing alongside the rise of like DevOps as a practice. So API, programmatic access to stuff is really important in DevOps, and the sort of rise of the cloud. Kind of commoditized hardware. So you can get a virtual machine to run your software on from any of these cloud providers. And to begin with, the differentiating factor with some of the big players like Amazon Web Services was they provided a better API. So I remember I used to work on a system that used Rackspace. And when Amazon came along, their API was just like threw that out of the water. We could start to write scripts, which we could run from our machine to be able to provision stuff rather than having to go back to the console. And then as you reduce the amount of time it takes you to make these changes, it frees up more time to work on maybe bigger, harder, more valuable problems for the business. So, yeah.
Or maybe just go ride your jet ski. That hasn't happened to me yet, though.
Well, yeah, I mean, because basically, I guess what it boils down to is you're trying, like, if we go back to what is DevOps, it's trying to be responsible and responsive to business needs. So if we're able to more quickly do things that we need to do, that doesn't necessarily mean that there's less work to do and we can all just go and ride our jet skis. We'll just be able to do more of different things.
And generally those extra things are the things that add value to the business, add value to your customers, create value for you at those complex problems, rather than, every company's got to run some stuff on a computer. So when that becomes commoditized, it becomes someone's job to run those computers for you, and you can then focus on the software that you put on top of those.
We've got a question in the audience from the audience from Krish going, is cloud automation a good career field? And I think you just sort of answered that, Alistair, going, yes, because you will be sort of enabling other things to happen, right?
Yeah, I mean, yeah, definitely. It's kind of my job. If I was to boil it down to one thing, that is what I do. And, I love it. It's enjoyable. It's not just lucrative in terms of, what companies are willing to pay, but I enjoy doing it. I enjoy solving the problems, and I enjoy working on that cloud layer, and then the developers and stuff come and sit on top of that layer. So you're sort of providing them with their own sets of automation and things. So, yeah.
So automation has layers like ogres and onions, in a sense. And I saw another question there around what kind of things can we automate in the cloud, and also sort of just a color of the cloud automation. I almost think it's kind of everybody to a degree is going to be touching on that, regardless of whether you're a application developer or coming from a traditional infrastructure background, or even if you're a business process. I mean, if essentially business process stuff is kind of been about some degree of automation, although the tooling typically was very desktop driven or, very non-programmatic, for want of a term. It wasn't, or at least required very bespoke tools. I think Alistair talked about APIs and Amazon and that, and I think one of the things that certainly then makes the automation easier is not having to have a particular bespoke tool that can only do its one job or at least having access to it, the sort of freely available access. So whether I want to use a tool of my own writing to talk to that API or a vendor supplied tool to talk to that API, as long as I follow that pattern, I'm able to leverage that, and I can have whatever kicking off those automated tasks. I can instantiate those events by anything like that. So just to jump back to that, what kind of things can we automate in cloud other than infrastructure as code? Where infrastructure as code, Alistair and Kai, you correct me if I'm wrong, would be fundamentally starting up something like an EC2 instance, that or set of instances and a virtual data center in that kind of concept. So some of the tools we're going to look at shortly, hopefully, are things that look at application level automation of your deployments, automation of your security checks for your applications. So there's a lot of those things. I think infrastructure as code, and automation. There's kind of oftentimes a blurry line between where those things start and end, but certainly they go a lot further than just creating the environment, the computer environment. But whether you standing up, as I think Alice is going to show us a bit later, a Kubernetes cluster, in a sense that's also infrastructure as code, but it's also platform. So a bit more than that. Do you guys want to talk tooling, or you want to?
Well, we've had a great question come in actually. When can we say that automation is not the right thing to do? When do you say I'm not going to automate that? I mean, I have opinions on that, but Mac, do you want to, or Kai, do you want to take that?
Go ahead, Mac.
Oh, throwing me in the fire. I would say, other than the word never, that it's never not a good idea. I think it's certainly very difficult to automate something that isn't a repeatable or predictable event. So if I want to always have let's say my delivery system sending out, my parcels for a company, sending out my parcels all the time. If I I have a system that knows how to handle square parcels, that I can automate very easily. But if I suddenly receive a parcel that is round, and I can't predict that it's ever going to happen, that kind of thing gets difficult. But I think for most cases, you could have a general case for automation and simply, almost as part of your process, have it throw to a queue the thing that it doesn't know what to do with. So in that sense, I'd almost say automation is never not the right thing to do, but you probably you can't always guarantee that you can automate absolutely every part of it.
Yeah, I think that's the part is know when to sort of pull back from the programmatic side. So say, let's talk about, you get some sort of alert that a particular part of your application goes down. And if there's a way that you know that it tends to break, well, you should probably fix that in code so that it stops breaking. But if there is a quick sort of way for you to mitigate a routing issue or something that is outside of your control, then that's a thing that you can automate a solution for. But the moment it becomes something that is not always that case, then it might not be the right place to automate a solution. You should still have an automated report, logging, name your verb here or noun, but you need to sort of know when it's going to require human intervention.
Yeah, and one extra thing on that is if it's going to cost you more to automate it than it would be to do it manually over the life cycle of the thing. So say you've got app development that you say is going to take a year, and there's a manual step in building it that takes a second, and you do it once a week, then it might not be worth spending more than 10 minutes trying to automate it because you're going to waste more time. But I mean, there's other aspects to that. Like if it holds up other things, then you've got to take those into account. But it's like if something's easy and you don't do it very often, it's not going to save you much time to automate it unless you're doing it for fun and you just want to see if you can. But generally, when you're working at a company, there are lots of time pressures, and you've got to work out if I invest the time to do this now, am I going to get the reward back in the future, or am I just kind of is it not worth it?
There's I don't remember if it was about automation or if it was about scripting in general, but they're kind of related concepts anyway. But I remember seeing something like, if you would do something 3 or more times, just automate it, you know? So, but that, obviously, take from that what you will, and your mileage may vary, because, you know, if you need to do something 3 or more times, but you only do it once every 6 months and it takes you 10 minutes, like, is it worth, again, like Alistair was saying, is it worth spending 6 hours writing the automation?
One of the scenarios that I was thinking of in terms of when, and it does talk to the timing of, for example, you've got an issue with an application, but the developers have already, you know, the team developing that have already indicated that they've got a fix on the way. However, they can't implement it right now. But it is essential for the stability or the availability of that service that, for example, terrible has to be restart. You know, you have to delete pods, you know, once a day to make sure it never gets older than that. Then that would be a good use case to put that in potentially as a short-term break fix, because it's something that has to be repeated and kind of needs to be done. And where I was going with that was back to the sort of concept of DevOps and who looks after what. Is a developer just going to write the application, or do they have a hand or a say in how it's run? Do they have a responsibility towards that? And so again, within a small team, where you're deploying and developing and rolling out your features and your applications, versus a large enterprise which may have backups being handled by a separate team, and one cloud provider handled by one team, a different cloud provider handled by another team. Part of the journey is towards being able to not have to make the requests to each of those different teams, but to be able to send your request through in an automated fashion and have it automatically be approved. But which point you spend time on, you might not have access to the developers in the particular scenario you're in, or you may not have access at that point of your journey to the cloud infrastructure team. So figuring out, you know, what you can do is important around that. What's going to take the most time and what's going to return the most value. I see, what is the best cloud service to automate processes? AWS, or Azure, or Google Cloud? Ooh, that's kind of fun for me. So yeah, that's where I put on my sort of open source kind of first ideology. It is an opinion, so it's not cast in stone. But I'm keen to see if Kai or Alistair have got any thoughts on that before I dump my propaganda.
I could go first.
Yeah, go for it.
Given that I work for Civo, I would say, you know what? I'm going to say, you know what I'm going to say? I'm going to say, what's the best cloud service is the one you're using, right? They can all do pretty much, you know, they will have different flavors of doing the same things, right? You can run, you know, they're platforms for you to do stuff on. They don't necessarily dictate what you can do on them, right? So I wouldn't say that one is better than the other, except Civo's the best.
And I would just say it doesn't really matter. If you're using some tooling like Terraform or something that we're going to look at in a bit, they're all abstracted away at this API layer, and it actually doesn't really matter. They might all be slightly different. So if you've got experience in AWS, the best one for you will be AWS. If you've got experience in Civo, because you already know the little nuances and quirks with that, you know, service. If I wanted to run a container in all three of those clouds, it would be quicker for me in AWS because I've used it for 5 years. But it doesn't mean that it wouldn't just be as easy to do it in the others. I just have to look at the documentation, because at the end of the day, all three want you to be able to run it as quick as possible, or Civo, right?
Yeah, so it might be a slight command difference between, you know, so you might have container run this or run this container, right? Like that's the kind of level of difference we're talking about.
So the questions, maybe it's a good time to ask the questions as we look towards some tooling is how do you choose, you want to automate things, how do you choose a tool, and maybe not after how do you choose a cloud, and some of the things that come out is like a very flexible tool versus an opinionated tool, a single purpose or a multi-purpose tool, single vendor, multi-vendor, a commercial product, or a product that's only supported by the community. So those are tooling related questions rather than sort of methodology and and process questions. But I lean towards something that can work on multiple cloud providers as far as possible. That feels to me like a safer option. But I also, that what Alistair said is really the wherever you are, if your development team is deeply embedded in AWS, for example, then you may already be using their tooling to automate. If you're not, then I would suggest start with something that isn't tied to a vendor, so that you don't have to learn another vendor's tooling later. It's more about not having to learn like CloudFormation and then Ansible and then Terraform and then because then it goes, okay, which one do I use? Where if you picked one that is fairly flexible and multi-cloud or multi-vendor, you'd have some good options there. Any thoughts on that? Yeah, see, Harsh Thakur, I hope I pronounced your name right, pointed out a comment about cloud agnostic. That's me just picking up someone who agrees with my opinion, eh?
No, because I think, especially if you're new to the space, right? You're looking to, you want to learn and be the best you can be. Why shut any particular door, right? Just, make sure that you can do what's required on your particular choice of platform, but be open to the fact that there are equally good choices elsewhere.
It's a good point. Like, I'm obviously a big advocate for Terraform because it's probably what I spend the majority of my day doing, writing, reading, changing, fixing. But there are platforms like Terraform which allow you to address not just multiple clouds, but also like anything that's got an API, anything where you can write code to change it or to interact with it. You can write, or there will be a community provider for it. So, I mean, in the UK, there's Domino's Pizza. There's a Terraform provider for Domino's Pizza. So if you want to order your pizza via infrastructure as code, it's technically possible. One of the companies I work for configure their own application, their customers and everything via Terraform. So it can allow the developers to move very quickly because they've only got to learn the one tool and all of its quirks to be able to do everything from ordering the team's lunch to onboarding a new customer. So
before I jump through a list of several tools, there was just something that I kind of wanted to look at what Keith mentioned. Keith talked about automation removing the risk of human error and also the reliance on individuals. I think that's a great way of putting it. And one of the things you tend to find with something like a tool like Terraform or GitLab or these other ones, when you use your automation to a lesser or greater degree, the automation tooling itself provides a degree of documentation that allows you to see and understand what was happening where. So as a new person onboarding into a situation, you can start looking into those. Now, I'm not saying that they're necessarily all really easy to read, but certainly there's a good amount of being able to look at the automation tool itself and see what is it that we do, or what is it that is supposed to occur. So that's certainly helpful. On the flip side,
Well, you also get to mitigate the risk of people leaving or people not being available or being taken ill. If your entire stack is configured via code and is checked into your version control system, there's no information in someone's head that you can't kind of extract from that without them. So worst case scenarios, you're never left without, oh, Mac was the only one who knew how to configure this web server, and he's left and he's taken his documentation with him. Well, with some of this tooling, you can at least see the code and the instructions it was taking to be able to make the changes.
I would like to just throw out one more thing, is how you handle failure also affects automation quite a bit. One needs to have both the soft and the sort of soft skill and the leadership space in order for you to do your testing and automated testing. But in as much as it removes the risk of human error, when you automate at large scale, when something goes wrong, it can go wrong quite broadly. And so obviously you want to catch those things in automated testing, but that's just something to kind of be aware of. It's not just something, oh cool, we took away a human being's ability to make a typo. No, you didn't quite. You just moved it early in the process. So if the typo occurs and is the right kind of typo, it now gets applied very broadly. So you can't have automation without automated testing to catch those kind of things. And so maybe that's the point, is like, what kind of tools can we use to test our automations to run through our automated testing for us? Alistair, what do you use to make sure your Terraform stuff is valid?
Well, good question. We have multiple levels of environment, so things go out to dev automatically, and then we have synthetic traffic on all our clusters and all our environments, so we can tell from a user perspective whether the changes have had any impact. This is specifically for like great big changes to Terraform plans, but when we also write our own Terraform providers, and those have all got unit tests and integration tests. So from a resource level, if I say I want to create a new user, I've tested in code when I do a release that if I change this value or if I add a new user, it's going to make the right API calls. It's going to interact with the system in the right way. I mean, this is a interesting point as well. Like testing in the infrastructure space is relatively hard because the scale of the changes we can make and the systems we interact with, it's not very easy to like abstract that away and doing like without deploying the whole thing onto a new cloud. It can often be really hard to know whether the change works or not.
Yeah, especially if they're strongly integrated or multi with lots of things and lots of integrations. Yes, which almost leads to though kind of the scenario where your testing is almost deploys a DR type scenario effectively if you're able to do that. But yes, it's not there. There would probably be a budgetary concern around some of this if you're doing it all the time, but there's certainly kind of levels to which one can do that. A couple of the tools that I wanted to just mention around infrastructure automation, we've talked about Terraform. Ansible is another one that I've used a lot of. Things that I've used less would be CloudFormation, which is AWS's tool, and I've never used the Azure thingy. And Google's presumably got something as well. So I don't know if guys are using anything specifically. I'm just looking at the comments. Outside of outside of infrastructure as code, there's tooling that helps with automation at the of applications. I think it will be pretty easy to pick a set of tooling there. Things that come up for me is GitLab, GitHub, Jenkins, Tekton, and Captain. So GitHub, obviously, with their GitHub Actions now allow events to trigger other events, which is automation. GitLab has their CI/CD pipelines, which are triggered as events, things that occur automatically when code is committed. The traditional Jenkins and Jenkins X also, again, they're sets of tasks that would be repeatable. For example, you commit a line of code to your application. Before it ends up being compiled and deployed, you want it to do maybe static code analysis. You want to do potentially, if it's going to be publicly exposed, you may need to have some automated security testing done against it. There's several of those things. So most of the platforms or software as a service that we consider around source control is typically including automation for code quality, code coverage, security tools as well. Then there's also kind of tooling that sort of covers both of them. So you can deploy applications via Terraform and Ansible. You can use Argo CD to create infrastructure for you and deploy applications, and likewise GitLab. So I think there's a good degree of things that go that way. Things you would include in your testing, obviously, it would be maybe things like SonarQube, Sonatype Nexus, but I don't know of anything else. I don't know of a lot of other pure testing space, things like Selenium and things like that you would include, but they're not automation in and of themselves, although I suppose you're writing Selenium tests, for example. And then the shameless plug from my side, what about release management? How do we automate that? So shameless plug for something like Argo CD. Well, that's not the shameless plug. The shameless plug would be something like Ahoy, which is an open source software product that does release management for workloads deployed on Kubernetes. And that's at github.com /open Ahoy. So yeah, I feel like it's safe to give that a shout out, since it is an open source product and the community can get involved in it. But those are some things that look around that. Things we haven't spoken about, like automating changes to business processes. There's a good degree. This is very focused on tech in that space. I see a question.
Yeah, sorry, I brought that up sort of a little bit early, but yeah, this one about on the degree of automation.
Alistair, you want to go for that?
Yeah, there's multiple ways of thinking about this. So both of those things are automating your input. So Terraform is like you run it, and you could run it as part of your continuous delivery pipeline, or you can run it from your computer. And the other one mentioned there is Crossplane, which kind of takes the idea of infrastructure automation and brings it into this Kubernetes world of continually applying or continually trying to reach the desired state. So from Terraform's point of view, you run it at a point in time, and it will detect the changes. So if someone's made changes manually, it will detect that, and it will make and apply only when you run it. But then if 5 minutes later Kai logged in and deleted something, I would have to then go and run it again, which is a manual step. Or I'd have to wait till my next deployment, which I guess is a manual step. But there are tools around like Crossplane where you define what you want, and it's automating your automation. It's running over and over and over again. So if Kai went and deleted something when we were using a tool like Crossplane to manage our infrastructure, it would just pop back up again.
If you are interested in Crossplane, sorry, this is another shameless plug. There's a video on this channel, on the Civo channel, featuring Crossplane and Victor from Upbound, who make Crossplane, and Anais from Civo. sort of doing a demo of exactly that, of like, let's delete this thing and see what, it pops back up. So effectively it's always trying to achieve the state desired.
There's always a question about if you've automated too far, if you've gone too far. So I use Terraform extensively. I've looked at cross-plane, and it's never quite fit the model that I'm aiming for, or that we're working towards, because say you get pager duty to 2 o'clock in the morning because your platform's decided it's unhealthy. And the mitigating factor is you log in and you change something. Like you log in and go, it looks like someone pushed a bad config and I want to fix it. And you log in and you go, well, we're losing hundreds of thousands of pounds an hour or a minute. I'll just fix it. I mean, it's really bad to just log in and do it, but you can fix it really quickly. If you're using something like Crossplane, which automates your automation, you'd see very quickly that you get called again because it's already gone and undone the change you made. So like there are risks involved, but also that goes the other way. So if Kai logged in and made some changes in production, I don't know why I always default to you, Kai. You look suspicious.
I'm exactly, I guess.
Then it would fix it for you. But I mean, it works both ways. It's kind of that level of control that you want, and that like you want to be around when your automation system makes a change. So like, you work 9 a.m. till 5 p.m. You don't necessarily want something happening at 4 o'clock in the morning. Like every time you deploy software, there's a chance that something's going to break. Every time a bit of code runs, there's more chance it's going to break something. So if you have a healthy platform at 5 p.m. and no one's working, do you really want some process running over and over again during the night? But there's lots of pros and cons for those, and we could probably talk for like 2 hours on the intricacies of it. But you can over automate, but you need to know where, like, what's acceptable for you, what works in terms of your like delivery process. Do you want stuff to happen automatically while you're not approving it and stuff? So
I guess I've sort of off the back of that, and maybe I'll ask this from Mac, or actually from Alistair as well, is like, is it important to, should you be designing this from the ground up? Should you be thinking about, whether, because, at the start we said, or I said maybe foolishly, like, if you can automate something and you weren't automating it before, that's something that you've done. But should you be considering these sort of really wide-ranging things, because they can be wide-ranging things, when you're first coming to design a system? As in, how do you choose what you're going to do?
That's an impossible question to answer. Like I guess within the team, you've got to look at the skills that you've got and the maturity within the team and the appetite from the business, like, and the technologies you want to use as well. So like Crossplane that we've mentioned involves running Kubernetes. It runs in Kubernetes. You might only need to run serverless functions, or you might not want to run Kubernetes because that, along with that comes a whole world of other problems or expertise or knowledge. Like it really depends on where you are, what skills and knowledge you've got in the team. So if your team are only going to deploy into AWS, Amazon Web Services, and they've used CloudFormation for the last 2 years on projects, would it be good to come in and say, yeah, let's use Terraform on this, considering the team have got no experience in it? Or would you say, well, we've got loads of CloudFormation, we know how it works, it's worked for us, let's use that again? Like it really depends on where you are and what you're trying to achieve. Like I would always default to Terraform because I've got years of experience in it, and therefore it's the right choice for me. But if I'm working with a team of like 10, 12 people and they've all got CloudFormation experience, yeah, I'll let them take that. There's more knowledge in the team on that. I might complain a bit because I prefer Terraform, but it's got to be what's right in the circumstance. And I know that's a terrible answer because everyone probably just wants me to tell them what tool to use. Terraform.
I'm going to largely agree with you on that, Alistair. I think something that I see a lot of is applications being delivered, and at some point they get handed over to somebody else to run, which may be terrible from a DevOps practice, but it's something that I see happening pretty much all the time. And the choice of tooling to maintain and continue the automation or patches or upgrades or the things that need to happen on an ongoing support, as the team that wrote the features or that the app itself may have moved on to other tasks. It certainly helps if they haven't chosen something that is not going to be. There's not a lot of knowledge in the rest of the organization around that tool. So, for example, a custom set of shell scripts or PowerShell scripts might not be the best way of approaching it, because the particular version of PowerShell using may no longer work in 6 months' time. So, whereas if you've chosen a tool that has a clear roadmap, there should be a good degree of future proofing in terms of its capabilities, which again leads to Terraform in my case.
Yeah, look out and see what the rest of the market are using, because unless your use case is very specific, you should probably choose one of the big tools or players in the field. And this goes for like most things in life. Unless you have a very specific set of requirements, which to be honest, most people don't, even though they like to think they do, just pick something tried and tested, unless you have a specific reason not to.
Yeah, like as much as fun as it would be to drive around in a Formula One car, most of us just need something that, has 4 wheels and an engine that turns, right? Because a Formula One car requires a lot of maintenance that we aren't equipped to deal with. And I think that's a sort of kind of analogy to, or, a metaphor to use here is, the future proofing. A garage will know what to do with your car, and an API should, to go back to APIs and automating through APIs, they should be able to, fall back, or like, no breaking changes should appear without you knowing about them, right?
Would now be a good time for us to switch across, Alistair, for you to show us some automation at work?
Yeah, sure. Let me share my screen.
And I'm going to have a look and see if there's been any other questions and queries.
So how do I present? There we go. So do shout if you've got any questions going forward. Happy to answer them. I'm going to fly through this relatively quickly because we don't have very long left. But one of the tools we've mentioned is Terraform. So I'm going to just talk about what it is, how it works, and probably some of the reasons why I like it. So this is actually adapted from a talk I did like 2.5, 3 years ago. But what's amazing is it's exactly the same now as it was then. So if I had written this in production 3 years ago, I could come along now and make changes and it would all still work. And it's all in Git and in code and everything. So, to me, that's a bonus, right? You don't have to rewrite it 2 or 3 years later. So we've said a lot, the word infrastructure as code. And obviously there's loads of ways to look at that and loads of tools. So Terraform is just one tool to solve the infrastructure as code or infrastructure as data problem. But broadly, it's where you define your infrastructure in a file, and then you check that into version control, which then allows you to do some of these kind of modern software delivery practices like code review. Or
Can I just very quickly interrupt and just go, when you say infrastructure, I know we've defined it before, but just for the benefit of this stream.
Anything that has an API. Anything that you want to configure, or anything a broad example would be your AWS setup. So you're provisioning your networking, you're provisioning your virtual machines, you're provisioning your, you can even provision your users. If you're using like a authentication service, you can provision your users in there. I've worked with organizations which configure their GitHub access, their GitHub organizational access via Terraform. So when a new joiner comes along, they add a line to a file, or they add a bit of Terraform code, run that, and it provisions the user. And then when they leave in 2-3 years' time, or whenever they leave, they won't forget to take them out, or it's very easy to take them out and not leave a trace of them in the system. So, it allows you to kind of keep it all centralized, keep it all audited. You know where you're going to go to change it, and you know how you're going to change it. The concept of kind of infrastructure as code also, I guess loads of people have seen this image, but if you haven't, it's kind of a joke within the software tech world about you making a change locally or in your development environment, and then when you release it into production, it doesn't quite work, or it works, but there's bugs, or it takes the whole site down. And the idea with infrastructure as code is you can use it to apply exactly the same set of configuration to every environment. So there's no, oh, Mac, did you remember to open that firewall rule to allow traffic between these two services? You've defined that in code. It's gone through peer review, and if it worked in your development environment, it's going to work in your other environments as well. So that's the kind of the thing we're trying to solve, is stopping breaking stuff, making sure it works everywhere. Terraform, it's maintained and written by HashiCorp, and they've also got loads of other open source. So it's open source, which is great. And it also, I think we look at this, it's what we call declarative, and I think we've touched on this before. You describe what you want rather than how you'd write a script, whether you'd say, add one node, add this firewall rule. What you do in Terraform or declarative things is you say, I would like one node. And then the software under the hood goes and works out how many nodes you've got. Oh, you've got 2. Okay, I'll delete 1. Or the example here, I want 4 rather than create 4. So I want 4, there's already 2, I'll add 2. Whereas an imperative one, you'd say add 4 instances, and then you'd have 6. And also it can be run over and over again without altering the state if there's been no changes. It's a command line interface. It's a program. The core component of it basically just manages state. That's all the core part of Terraform does. It manages, it stores some information about how many EC2 instances you've got running, or your GitHub user. It stores that. And then all of the functionality is added via plugins, and they're called providers. So the Terraform AWS provider provides all the functionality to be able to say, I want an EC2 instance, or I want an EKS Kubernetes cluster. And these providers can be anything. Like we've said, they can be Domino's Pizza, or AWS, or Civo Cloud, or GitHub. Anything that's got an API, you can write a provider for. And if you go on GitHub or on the Terraform registry, you'll see all of the possible providers you can install. They've all got documentation, and we'll kind of look at how easy it can be to use those. We've mentioned state, and it's kind of it's a JSON representation of everything you've described at the point in time it was last run. And the reason it stores state is so that this thing called state drift. So if you created 2 EC2 instances and then Kai again logged in and deleted one, it would realize that you wanted 2. If you ran it again, because it's in the state, it would know that that EC2 instance disappeared, and it would create a new one. And this also helps with things like things that have got random IDs. It maps them back to like a unique name as well. So you can have like Kai's EC2, and then it would map back to a random thing, and it just maps between those. So then it knows that Kai's has been deleted, and it will recreate Kai's rather than Mac's. Don't lose your state file if you're using Terraform. So if you run it in its default configuration, it will store it on your computer. If you lose it and then try and rerun it, it will break probably, or you'll end up with 2 of everything, and it won't know how to delete the ones from the first state file. So don't lose it. We've touched a bit on providers. So anything you want to do with Terraform, you do it through a provider. So make HTTP calls, or you can do stuff on the file system like zipping and unzipping files. We've got our cloud providers, databases, Kubernetes clusters. You want to create a new table in your Postgres database. There's a Terraform provider for that. You go Postgres database and tell it the name of the database or whatever, and it will create it. And there's a link to the list of providers, and there are so many. I'm just going to briefly touch on syntax. It's basically you define what's called a resource, and then the first part of that where it says AWS, it basically tells it which provider to use. And then the instance section is within this provider, I want this thing. And then the next bit, my demo instance, is the name of it, the local name inside your code. And then within that block is the configuration. So instance type, that's a small instance with not very much RAM and CPU, but equally I could change that string there to be like something massive that costs hundreds or thousands of dollars a month. But it's defined in there and I know what it will be. And you commit that into your Git repository. And if you change it, I would raise a pull request, or I would ask Kai to look at the changes, or Mac. And if they agreed, they could let that through, and it would make the change for me. There's some example code there. We're going to briefly look. We really haven't got very long, so I'm actually going to just skip through the code bits, but I'll explain what it does. It sets up all of these things. So you start out with nothing, and basically it creates a domain name. It creates what in Amazon what they call an application load balancer, which takes traffic from the internet and can pass it through to something that's running. And then it basically configures the target group and the things that are running. It configures everything. And if you look, like we define things like, what ports we're going to use and the protocols, and, the health checks on things. So if it's unhealthy, Amazon have some automation. So if it's unhealthy, Amazon have automated some of this stuff for us, and they'll restart things automatically. And then, I'm gonna skip through that. There's quite a lot of gotchas for running Terraform. This comes from like 3 or 4 years of experience running it. Don't let the list put you off. Some of these are quite advanced use cases, but things you have to think about. I'll leave it on the screen. We've really not got very much time left, so we'll leave some time for questions. But yes, thanks for listening. Watch it back if that didn't help, or reach out to me on Twitter. I can talk about stuff.
Or on the Civo Slack.
Or on the Civo Slack. I am indeed there.
Yeah, we have...
Where there is an automation channel just dedicated to this topic.
I was going to say, like, if you can't think of questions right now on the stream, have a look. The Civo Slack channel, you will get an invite to it as soon as you join Civo. If you have any questions, all of us will be there. There's also the Academy, which is civo.com/academy if you want to learn about Kubernetes. And there is the quiz linked to in the description. So make sure you look through that. Some of the things will have explicitly been said on this stream, and some of the questions will probably need you to have a look around and use your favorite search engine if you don't know the answer yet. But yeah. Thanks everybody for watching. Thanks Mac and Alistair for joining again. Mac for the first time, Alistair again. And be sure to tune in to, I think the next one is next week. And next week's session is on security and DevOps and security and thinking about building secure applications from the start. So, well worth tuning in for it. And yeah, thanks from me as well. Thanks for watching. And bye, everybody.